Hello and welcome to our class today. We're going to learn on fluid mechanics and our topic is dimensional analysis. Dimensional analysis. So simply, dimensional analysis is a method of dimensions. So you can simply say that this is a method dimensions. And in every day, if you've learned science, you'll find that you'll be dealing with dimensions and a number of equations. Now, in dimensional analysis, we are going to learn the relationship between quantities that are involved in an equation. For example, we have physical quantities. And on physical quantities, we have the mass, which is denoted capital M. We have the length, which is denoted L, and time, denoted capital T. So realize all these, I'm placing them in capitals. Mass for the M, length L, and time T. So all these are physical quantities, or you can refer them as primary quantities. Sorry. So it's not exhaustive because you also have the aspect of temperature here. But we are not going to deal so much on temperature. In our class, we are going to do most with the quantities of mass, the length, and time. Now, for the relationship, where we will have maybe in a quantity where you have a mass and the length, or length and time, we have them as secondary quantities. So we also have secondary quantities. So secondary quantities are also known as derived quantities. So we call them derived quantities because they are derived from the primary quantities. For example, let's say velocity. So from a definition, we know that velocity is change in distance per unit time. And distance simply is an aspect of the length. So L, when we say per, it simply means division. So L over T, or L divided by T. So you find that L is from the primary quantity and T time is also from a primary quantity. So how we're going to denote velocity here is L and T negative 1. That is it. Let's use another example, like density, for example. So by definition, we know that density is mass per unit volume. And mass, like we said initially, mass is denoted M. Per is like division, divided by volume. So volume is a factor of length. So it's simply L times L times L. That's why we normally have it in cubic meters. So we're not writing M instead, but L raised to 3. So this is ML power 3. So how are we going to denote density? Now this is a symbol of density, is denoted ML negative 3. So I'm going to attach my video with a table containing the secondary quantities, that is with the quantity, the symbol, and the quantity written in form of M, L, and T. So these are the secondary quantities or the derived quantities, and I've categorized them into three. We have the geometric quantity, we have the kinematic quantity, and the dynamic quantities. Now, in geometric quantities, we have the area and the volume. So area and volume are simply from the dimension, that is dimension in terms of their length. So these are the symbols, and we are writing their dimensions in terms of L squared for the area and L cubed for the volume. Kinematic quantity are derived from the length and the time, or the dimension of the length per unit time. The likes of velocity, acceleration, angular velocity, angular acceleration, discharge, and gravitational acceleration. So you have the units as listed in the table. The last quantity type is the dynamic quantities. And for the dynamic quantities, you find that we're now introducing the aspect of mass. So it can either pick it from the three primary dimensions, the m, l, and t, and that's why you're having the density, the weight, force, pressure, power, momentum, specific weight, and surface tension. So students, you can take your time to look at all the three quantities, because in our following classes in fluid mechanics, we will be using these dimensions in calculating, or rather doing what we call dimensional analysis. So get to know each and every one of them. Thank you so much for watching, and see you in our next class.